Hello friends, welcome to the channel. Class 10, Chapter 1, Chemical Reactions and Equations. Consider the following situations of daily life and think what happens when. That is the daily life things we basically see in our daily life. This changes happen. Milk is left at room temperature during summers. What happens? Milk turns to curd. Okay. An iron tawa, pan or nail, any item of iron is left exposed to humid atmosphere. What happens? Rusting of iron. Okay. जंग लगना जिसे कहते हैं. Grapes get fermented, turns to kishmish. Food is being cooked. Food gets digested in our body with the help of digestive juices. We respire. Okay, so all these things, yes, all these things goes under a chemical equation. I'm sorry, chemical reaction. These all things go under a chemical reaction. So see, in all other situations, the nature and the identity of the initial substance. The initial substance means pehle what it was. It was a milk. Then later on it gets get turned into the curd. Whenever a chemical change occurs, that is a chemical change occurs, we can say that the chemical reaction has taken place. There are some activities. We'll see activity 1.1. So this is the activity of magnesium ribbon. By burning magnesium ribbon, you get magnesium oxide. Yes, we'll say how we'll get. Clean a magnesium ribbon with about 3 to 4 centimeter long by rubbing it with a sandpaper. Hold it with a pair of tongs. Burn it using a spirit lamp. So this is your magnesium paper, 3 to 4 centimeter. You're holding it with these are your tongs. Okay. Then burn with a burner or a spirit lamp. Okay. Burn the magnesium ribbon, keeping it away as far as possible from your eyes. So here what do you observe the chemical reaction is? The magnesium ribbon burns with a dazzling white flame. Okay, magnesium ribbon, when you're burning, it burns with a dazzling white flame, changes into a white powder. This powder is magnesium oxide. Okay, it is formed due to the reaction between the magnesium and oxygen and present in air. Okay, so when you burn magnesium ribbon with the help of burner, okay, you get magnesium oxide, that is a white powder, and it burns with a white dazzling flame. Okay, next activity. Take lead nitrate solution in a test tube, add potassium iodide solution to this. What do you observe? So what we observe is this: hydrogen gas, formation of hydrogen gas by the action of dilute sulfuric acid. Dilute money, see, concentrated means pure, dilute money water is mixed or any other solution is mixed, aqueous solution. Okay, acid on zinc. See here, you can see from the above activity we can say that any of the following, that is observation: change in state, change in color, evolution of gas, that is hydrogen gas is evolved, and change in temperature. Okay, next. So chemical equations. So in activity 1, we came to know that when magnesium ribbon is burnt, we get magnesium oxide, right, in the presence of air. Okay, so how? When a magnesium ribbon is burnt in oxygen, it gets converted into magnesium oxide. This description of the chemical reaction in a sentence form is quite long. So it can be written in a shorter form. The simplest way to do this is to write in the form of a word equation. That is magnesium. These are the reactants, right? When magnesium is reacting with oxygen, we get magnesium oxide. Okay. So this is a word equation. Next, the substance that undergo chemical change. So which substance is undergoing the chemical change? That is reaction 1.1. This magnesium is going. Magnesium and oxygen are the reactants. The new substance is magnesium oxide, formed during the reaction as a product. So the substance where two substances get reacted is called reactant, and they produce a product called product. Okay, what their answer will be, we call that as a product. Okay, a word equation shows the changed reactants to products through an arrow placed between them. See, the reactants are written on the left hand side. Reactants are basically written on left hand side, and the products are written on the right hand side. Okay, similarly products are written on the right hand side with a plus sign between them. Why we say plus? Because we are going to add them. Yes, the add them in the sense it's not like addition. It's like, say, in the present it might be oxygen, sometimes it might be any acids like HCl, nitric acid, anything it can be. So basically these two things are going to react, right? So we are going to add it, means addition sign. The arrowhead points towards the products and shows the direction of the reaction. That is, this is the direction of the reaction. That is, when these two are reacted, we get a product of magnesium oxide. Okay. See, example, you prepare palak paneer, right? At the beginning we use palak, we use so many spices and all later on. Okay. So what all palak plus spices plus water, what everything you use, right? When everything you use, at that time your product will be palak paneer. You name it as a palak paneer, right? Before, only after using palak and paneer and water, you don't say it's a palak paneer. But when you combine these all things together, only just adding palak and paneer doesn't make palak paneer. You require spices, you require water. Yes, you require so many other things also. Then only you can prepare palak paneer. Same way, for elements also it is. See, when magnesium and oxygen reacts, they get magnesium oxide. Okay. Next. So, how to write this chemical equation? Before it was a writing in words, now it's a chemical equation. See, magnesium. Don't you think it's too long to write? Oxide. Yes. So the short form is MgO. Starting MgO. Yes. It is there any other shorter way for representing chemical equations? Chemical equations can be made more concise and useful if we use chemical formula instead of words. So these are the chemical formulas. The chemical equation represents a chemical reaction. If you recall formula of magnesium, oxygen and magnesium oxide, the above word equation can be written as. So Mg plus O2, that is MgO, that is magnesium oxide. Like how it was magnesium plus oxygen, yes, and we wrote as a magnesium oxide. Okay, so how short form is it? Mg plus O2 gives MgO. Yes. Count and compare the number of atoms of each elements on the LHS and RHS of the arrow. Is the number of atoms of each element the same on the both sides? If yes, then the equation is balanced. If no, then the equation is not balanced. Such a chemical equation is a skeletal chemical equation for a reaction. That is, we'll see in equation 1.2. Okay, sorry, we'll see in the equation 1.2 is a skeletal chemical equation for the burning of magnesium in air. Okay, see, in activity they have given such a lengthy process, like when magnesium ribbon is burned, so and so. So you have to write first this, that is the magnesium sorry this equation in the word equation form, but later on you can just write with the help of chemical formula, that is magnesium chemical formula, oxygen chemical formula, and magnesium oxide chemical formula. Yes, so it will be magnesium oxide. So this is the skeletal form. Skeletal money, no words used, only the formulas are used here. Okay, skeletal form of equation. Next, how to balance the chemical equation. Recall the law of conservation of mass that you studied in class 9. Okay, mass can neither be created. See, what is the law of conservation of mass? Mass can neither be created nor be destroyed, but in a chemical reaction. Okay, law of conservation of mass is mass can neither be created nor destroyed in a chemical reaction. That is the total mass of the elements. The total mass of the elements present in the products of a chemical reaction has to be equal to the total mass of the elements present in the reactants. Are you understanding this point? So the total mass of the elements present in the products. See, the total mass of the elements present in the products of the chemical reaction has to be equal to the total mass of the elements present in the reactants. That is, both the sides should be equal. Yes. In other words, the number of atoms of each element remains the same before and after a chemical reaction. Hence, we need to balance a skeletal chemical equation. Is the chemical equation 1.2 was magnesium oxide equation was balanced? Let us learn about balancing a chemical equation step by step. Okay, so we'll do this in 1.3. This is words equation, right? Because the equation is written in the word. Zinc plus sulfuric acid, that is Zn plus sulfuric acid is H2SO4. Okay, and zinc sulfate, that is ZnSO4 plus hydrogen H2. Okay, see, zinc sulfuric acid, zinc sulfate is formed. Okay, ZnSO4. Then hydrogen is the single element. So how to balance this now? Is it balanced? First let us check. Zn, one element, 1. H2, H2. SO4, SO4. Yes, it's a balance equation. Okay. Let us examine the number of atoms of different elements on both sides of the arrow. That is, Zn has one element. Yes, both 1, 1. H2 has 2, 2. Yes, 2 and 2. Sulfate has 1 and 1. Oxygen has 4 and 4. Yes. So LHS and RHS should be equal in the balanced chemical equation. Next, let us try to balance the following chemical equation. Now there is a new equation which is not maybe balanced. Fe plus H2O, that is Fe3O4. Let us check out here. Fe is iron. Okay. Fe plus H2O, that is Fe3O4 plus H2. Is it balanced? Comment in the comment section. Okay. No, this is not balanced, right? Fe plus H2O. Okay. See. So how to balance this? To balance a chemical equation, first draw boxes around each formula. That is this. See, you can see here, they have shown. But we'll also do here. Yes. These two elements are 1. So, 1 box for them. Yes. Next. Around each formula, do not change anything inside the box while balancing the equation. Now, step 2 is list the number of atoms of different elements present in the unbalanced equation. So iron is 1, but here it is 3. RHS side. So this is LHS. Don't get confused. And this is RHS. So how you are going to balance the equation is iron is 1. See here only 1. But here 3 are there. Can you see this? 3. Okay. Hydrogen. 2 molecules, 2 molecules. Correct. Oxygen 1 molecule but 4 molecules. See, LHS side it is 1 molecule, but RHS side it is 4 molecule. So this is not actually a balanced equation. Step 3 will see it is often convenient to start balancing with the compound that contains the maximum number of atoms. So who's carrying a maximum number of atoms? It may be reactant or a product. See, these are reactants and these are products. Okay. Select the element which has a maximum number of atoms. That is oxygen. Using these criteria, we select Fe3O4 and the element oxygen in it. Okay. There are 4 oxygen atoms. You can see RHS side. There are 4 oxygen atoms on the RHS and only one on the LHS. See what step 3 is saying is for balancing the equation, the maximum number of atoms, that is compound that contains, which compound has maximum number of atoms. Okay, Fe3O4 has maximum number of atoms. Okay, so we have to take from the maximum number of atoms itself. See, it may be reactant or product. We don't see that it is reactant or product. We can take from any of them. In that compound, select the element which has a maximum number of atoms. That is, if it might be on LHS side, sorry. If it is like Fe3 or if it may like Fe plus H2 6. Okay, so 4 is greater than 6, right? So we would have taken LHS side, that is reactant side, but O4 is right now it is greater, okay, for this equation. So we are taking the RHS side. Okay, in that compound select the element which has a maximum number of atoms. Okay, using these criteria we select Fe3O4 because oxygen has 4 atoms and the element oxygen in it. There are 4 oxygen atoms on the RHS side. So we have selected Fe3O4. See, can you see the larger number from this? Yes, 4 is the larger number, right? So we are selecting the RHS side and that to the element of oxygen. Okay. And only one side on the LHS. Next, to balance the oxygen atoms, how we'll write this? Atoms of oxygen. Initially it was 1. Yes. On the left hand side it was 1. And in products it is Fe3O4. In products it is 4. To balance it, in reactants 1 into 4. Okay. And here 4. To equalize the number of atoms, it must be remembered that we cannot alter the formula of the compounds or elements involved in the reaction. For example, to balance oxygen atoms, we can put coefficient 4. Yes, as 4H2O and not H2O4. Yes, see, you cannot change water formula. This is actually water formula, right? H2O. You cannot write H2O4. No, you cannot change this. I mean, sorry, you cannot change this. This is not the water formula H2O. Only H2O is the water formula. H2O4 is not the water formula. So, for example, to balance oxygen atoms, we can put coefficient. That is, this 4 can be written here. 4 molecules of water. Okay. Now, partly balance the equation becomes, see, Fe plus 4H2O. Are you seeing? Yes, and now it is balanced. See, H2O4 cannot be written here. No, you cannot write that because water formula is only H2O. Okay, so you can coefficiently mane 4H2O and not H2O4. Okay, now this equation is balanced. Next, step 4. Fe and H, that is iron and hydrogen atoms, are still not balanced. Why? Because see, iron is single. I'm sorry, iron is single, and here it is 3 atoms. Okay, so now pick any of these elements to proceed further. Let us balance hydrogen atoms in partly. See, here hydrogen is 6 molecules, but here 2 molecules. Okay, I mean 2 atoms. So now again we'll see. To equalize the number of let us balance hydrogen atoms in the partly balanced equation. To equalize the number of hydrogen atoms, make the number of molecules of hydrogen as 4 on the RHS. See. Yes, initial it was 4. 4 2s are 8. Yes, this is reactant and this is product. Again, don't get confused. So initial money this side. Okay, 4H2O it was, right? Because we are balanced here. So it is now 4H2O. Yes, this 4H2O. And in products it is 2. Yes, this 2. So how you are going to balance? See, 4 2s are 8. So you have to write 4 also here. Okay, 2 4s are 8. Okay, see here they have given. The equation would be Fe plus 4H2O. See, first they have done of hydrogen, then they'll do of iron. Okay. So, see, first they have equalized which element? Comment in the comment box. Okay. The equation would be iron plus 4H2O. 4 molecules of 4 water molecules plus Fe3O4. That is iron oxide. And next 4 molecules of hydrogen. See, 8, 8. Oxygen 4, 4. Still iron is not balanced here. Can you see? Why? Because 3 molecules and 1 molecule. I mean atom. Okay. Examine the above equation and pick up the third element which is not balanced. That is third element. You find that one element is left to be balanced. That is iron. So now atoms of iron. Initial it is 1. Yes. And in products it is 3. To balance what you will do? 1 into as they have given here. So this is 3 already. It will become 3 Fe. So see, to equalize Fe, we take 3 atoms of iron on the LHS side. See, 3 Fe plus 4 H2O. That is Fe3O4. Now all are balanced. 3 Fe, 3 Fe. O4, O4. H2, H2. Not H2. It's 6 H and here also 6. Okay, 4. Sorry, not 6. 8. 4 2s are 8. 4 2s are 8. Yes, is it correct? Now your equation is completely balanced. See, this is your balanced equation. Finally, to check the correctness of the balanced equation, we count atoms of each element on both the sides. See now, 3 Fe, 3 Fe, 4 H2O, 4 H2, O4, O4. Yes, this is the balanced equation. Okay, the number of atoms of elements on both the sides, okay, that is in equation 1.9 are equal. This equation is now balanced. This method of balancing equation is called hit and trial method. Okay, hit and trial method, as we make trials to balance the equation by using the smallest whole number coefficient. Okay, Next, in step 7, writing symbols of physical states, carefully examine the above equation, that is 1.9. Say this. Does this equation tell us anything about the physical state of the reactant and product? No information is given in this equation about the physical state. Yes, to make a chemical equation more informative, the physical states of the reactants and products are mentioned along with the chemical formula. So these are the chemical formulas: Fe, H2O, Fe3O4, 4H2. Okay, chemical formula. So the gaseous, liquid, aqueous and solid states of reactants and products are represented by the notations G, I, AQ, S. Yes, respectively, the word aqueous mane AQ is written if the reactant or the product is present as a solution. The balanced equation in 1.9. See, before there is no symbols like G, L, AQ, S. See, aqueous, gaseous, but now they have given so writing symbols for physical state. See here. G1 see S, G, S, G. Okay. So G stands for water. Oh yes. To indicate that in this reaction, water is used in the form of steam. This is also, sorry, this hydrogen is also steam in the form of gas. Usually physical states are not included in a chemical equation unless it is necessary to specify them. Next, sometimes the reaction conditions such as temperature, pressure, catalyst. See, catalyst is basically which increases the rate of reaction. Yes, like booster dose. Okay, catalyst which increases the rate of reaction, etc. For the reaction are indicated above and or below the arrow in the equation. See, for example, they have given you an equation. See, carbon monoxide CO, that is G, that is in the gaseous form, plus 2H2 again gaseous form. See, this atmosphere they have mentioned at 340 atmospheric pressure. That is what it is from CH3OH alcohol. That is, you can see here 4. Is it balanced? No. No, yes. Comment in the comment section. Okay. Then next equation 6CO2 aqueous money in the water solution. Okay. What is L? H2O. Yes. In the presence of sunlight and chlorophyll, glucose is formed. Yes. So oxygen again aqueous, that is water droplets. H2O is L. Okay, using these steps, can you balance equation 1.2 given in the text earlier? Next, balance this equation and comment me. Okay. Comment section, answer this. I'll roughly just say, but I'll not write. See, one atom of magnesium, one atom of magnesium. 2 atoms of oxygen, 1 atom of oxygen. Yes. So this is not a balanced equation. So how you'll write? Now 2. LHS side has 2 atoms of oxygen. So it will be MgO2. Yes. And now is it balanced? 1M, 1 Mg plus O2, that is MgO2. Yes. So I have just explained. You have to comment the answer. Yes. Okay, thank you for watching the video. Any doubt, please go through this chapter once again. You'll learn here how to balance the equation. Yes. Thank you for watching the video. Goodbye. Don't forget to like, share and subscribe.